Now we get to number 6. Number 6, you're on a spinning ride at the park, and the mu between you and the ride is 0.489, and you're sitting 1.57 meters from the center. How many of you have been to the park before when you were a little kid, and your dad had to crank the thing and turn it and spin it, and you were like, go faster? Okay, so here we have a... Yeah, so here you are, and here's your brother, and here's your little sister, and you're all on the ride, and your dad starts spinning you, and pretend that, you know, there's no safety regulations here. So there's no handles or anything. And so you can't hold on, and the faster he makes it go, eventually people start flying. Okay, so how come they did not fly off at the same time? Different amounts of friction. What's holding you on there, again, is that concept we were talking about yesterday, that as long as the friction force is bigger than or equal to the centripetal force you need, then no problem. You stay on the thing, and everybody's happy. But what happens is, as I'm spinning it faster and faster and faster, what's changing? Yeah, this one is getting bigger and bigger and bigger, and this one's not getting bigger. So eventually what happens is, where FC becomes bigger than FF, now suddenly I can't hold on anymore and I go flying off the ride. No. So that's the part that gets dangerous. So what we want to do is figure out what's the biggest we can get, and that's the point where these two are identical. And again, the friction force equation we learned way before is just we learned G, and the FC equation that we just learned yesterday is mv squared over r. And again, you should notice that the m's cancel out, and if I'm looking for what's the fastest speed I can go, then the r needs to come over here, and to get rid of this, I need to that, and so if I make it look not so ugly, I'm basically going to have the square root of rug is the v. So, yeah. So the r was what? 1.57. And the mu was 0.489. And G was, that was a tough one. And so what was superfluous information there? Your maths. If you did it the long way, you might want to do it, but we like to do the algebra. I like to do the algebra ahead of time because a lot of times things cancel out and it makes it easier. So all I had to do is plug straight in like this, and I will get the right answer. You're going to have a question just like that on the test. Yay! Yay! Because that was easy. We love easy. Hooray for